Do you have an interview scheduled after this?
Um, I think I have an hour interview every hour on the hour. So 10, 11, and 12.
What about from 9:30 to 10? You don't have, right?
Nope.
So we are
I'm
fine to
free.
talk right now.
Yeah, yeah.
Okay, cool. No worry. Cool. Sounds good. Okay. So yeah, hi Ryan. Um,
Howdy, howdy.
sorry for the this kind of introduction because I was trying to talk to Nidhi, but
Yeah.
yeah, you know what? Welcome to Valodine. You know, it's
Thank you.
always a pleasure to interview candidates like you. Uh, and can you introduce a little bit about yourself?
Yeah, so I just graduated
Sorry, you
this
can't see me,
semester.
right?
Oh,
I'm sorry. I didn't realize. Okay, cool. Choose integrated webcam. Some reason my video is not enabled. Let's see. Okay, can you see me now?
um, no.
No. Okay, HD. No, it doesn't matter. Yeah, fine. Okay, now you can. Now you should be able to see.
Yeah, I see you now.
Hey. Okay. Anyway, so hey, yeah, can you introduce a little bit about yourself?
Yeah, so I just graduated this semester. So 2 months ago, I think, I got my bachelor's in electrical engineering. We
Cool.
have a
Congratulations.
thank you. I have a focus in control systems. Uh, my senior project was a wireless EKG device,
Mm-hmm.
and I'm currently employed at Shriners Hospital for Children.
Mm-hmm.
Uh, my official title, I think, is data entry, but I'm doing something much more akin to data engineering.
Got it. Got it. And what's your interest and why did you want to interview with Valentine?
I think LiDAR is a really cool technology, and I would love to be at the base of it. You know, kind of developing the lowest levels of it and watching it grow.
Okay,
I
got
think
it.
that'd be
Cool.
cool.
Okay, cool. So yeah, I'm just going through your resume here, but just to give a little introduction of this role and our team, right?
Hmm.
So we are, yeah, of course, we are a lidar company, but specific to the lidar company, we are in a, we develop the ASICs. That's basically the chips for the for a specific aspect of the lidar, you know.
Hmm.
And we have multiple chips that we work on, and we want to integrate these chips into the product. So we design the chips. Okay, first of all, we kind of study the system. We design the chip, and then we have to integrate this chip into the system. So it's it's a pretty well vertically integrated process.
Hmm.
Okay. So your the position that you're interviewing for is basically something called a post silicon validation engineer.
Yeah.
And what that does is because you're coming from you just finished your bachelor's, right? So I'm going to give it explain a little bit in more detail so that you get an idea of it.
Hmm.
So what you do in a post silicon validation engineer is once you get the chip back, right? You test it for specific parameters. Like we have developed the chip for a specific reason, right? So what you will be doing is you'll be looking at the lidar. Okay, what is required in a lidar, and then you'll be kind of emulating the signals that will really come into a lidar. Okay,
Hmm.
and then you'll be testing the chip. How does the chip perform? Where do where, how can it deliver the does it meet the specs? Does can it be integrated in the lidar? Things like this. Okay. So it's a very cool position in terms of learning because you're testing. To test, you need to understand how something works, right, in the first place.
Yeah.
Yeah, and considering our companies like we are a fairly not a very big company. We're a fairly small company. So the way it works is it doesn't stop there. Like in most big companies, you would stop at testing, and then you're like, okay, hand it over. But the way it works in our companies, or any company of our size is, yeah, you test it, and then you kind of uh, get involved in the actual integration.
Oh,
Okay,
that's
so
cool.
it's a very good learning. Uh, it's a very good opportunity to learn. That's how I would say. That's how I look at it.
Hmm.
Yeah. So yeah, that's the little background on that. about this role here.
Hmm.
So yeah, going a little bit through your resume, I'm looking at you seem to be very interested in a lot of uh, you know a lot of mini projects which you have done on your own. Some did you do this as a hobby? A lot of these things, like the electronic kit display, or was it part of a professional setup?
Most of that was for schooling.
Schooling. So it's okay. So you're very much interested in things like this, right?
Hmm.
Right. So and then can you tell me a little bit about your model elevated design? What you exactly did over there?
Yeah, so that was a much older project. That was something I did back in high school.
Hmm.
During my senior year, we had an engineering academy. Um, it was a system of sort of pre-built parts. It was a very simple system where we had photoresistor sensors and we had some rudimentary switches. And
Hmm.
then I actually assembled the tower. I put switches on there and I set up my sensors along it. And then I had a car moving up and down along a motor. And then I basically programmed the rudimentary state machine that told the elevator move up and down and then what floor to go to, when to stop, that kind of thing.
And how did you program it? You programmed the IC directly?
Oh man, I forget. I think it was something specific to the hardware and software that we were using. I
Hmm.
think it was a very rudimentary system.
Okay.
Yeah, it was 6 years ago. Yeah.
Okay, cool. So then the next project I'm seeing is you developed a chest strap with electrodes. ICs
Yeah.
and microcontroller to send six lead. Okay, can you again give me a explain what exactly what's happening here?
Yeah, so that was my senior project. I was on a team of 5,
Hmm.
and what we wanted to do was build a EKG device, but we wanted it to be wireless, so it was easier to wear all the time, so you could have long-term data. And then also we wanted it to be uh, something that was simpler to use, so that the elderly or people who were disabled could use it. Because traditionally, an EKG machine has wires running all over your body, and they have mobile ones, but it's this big chest strap that you have to wear, and it's a big box, and it has wires running down all your limbs, and it's
Got it.
really inconvenient. And we wanted to simplify that and make it more convenient. Uh, Also, the electrodes that go onto the skin normally have a gel,
Mm-hmm.
and that gel is a potential skin irritant if you wear it for too
Mm-hmm.
long. Not to mention, people don't like putting gel on. So we used dry electrodes, which means we didn't have gel. We had an alternative system of ensuring that we had good contact, because that would make it easier to wear for a long amount of time, and it would increase patient cooperation, basically. People are more
Cool.
likely to actually wear it and use it if it's more
Got it.
comfortable to use.
Got it. So for this EKG machine, what's the concept? How do you determine what exactly are you doing in the EKG machine? I mean, can you
So,
tell me the technicals or the science behind it?
not down to the exact medical level,
Or
but
not, on the electrical level at least.
yeah. So, what we found is we actually had looked up how do EKG machines work, and we had found all these circuits examples.
Mm-hmm.
And initially, in the early stages of testing, we actually built these by hand. We have obviously we have huge swaths of resistors and capacitors and the such, and we put these circuits together to try pumping signals in one end and getting them out the other, kind of just making sure that we had the basics down.
Mm-hmm.
Uh, from there, we found a chip that has all of those filters and sensors built into it. So we used a couple of those
Mm-hmm.
in a new order to try and accomplish our goal, because what we have is those 6 leads usually require what's called a reference node, which is an electrode somewhere else on the body
Mm-hmm.
that you can use to basically get the body's background noise to compare the signals against, so that you're filtering everything out properly. We found that we could use one that was still on the chest, but slightly further over.
Mm-hmm.
And from there, we were able to cancel out some of that noise, and we were able to get everything onto just a single chest strap. So we ended up using 3 of these chips that they were built for EKG devices. And we basically used the first one to create a virtual node that we could use to measure across the heart with. and then the other two were working normally, basically.
Sorry, can you repeat that? The
The
first one.
other, the first one we used to create a virtual node behind
Okay.
the heart so
Okay.
that we could measure electrical signals across the heart.
Uh-huh.
And the other two fed in the rest of the electrodes normally,
Got it.
using that first one as a fourth input. So it had that reference.
Okay. And what did you do with this data that you got from here? Did you digitize it? Because that's probably an analog signal, right?
Yep, it's an analog signal. Um, these chips already had quantizers built into them.
Mm-hmm.
So from there, we sent it through a STM32, which
Mm-hmm.
has a Bluetooth module in it, and we sent that off to a smartwatch device. This was a team of 5, so I was working mainly on the strap itself, and we had computer engineers who were working on the smartwatch half of it.
Got it. Got it. So you were on the electrical aspect of things.
Yep.
So what, if I summarize what you tried to, how the project went was, you looked at how the EKG machine worked, read up about it, looked at a bunch of circuits, tried some of the circuits, tried to emulate them, and but then I think in the midway you realized that there's probably an IC that can do all this. Okay, but that's the usual process, right?
Yeah.
That use the that's a very right way to go about it, because you wouldn't know that there's an IC to do unless you try to build it in the first place, right?
Yep.
Cool, very cool
That's
project.
exactly what happened.
Okay. And is that and what made you join become an electrical engineer? Instead of a mechanical engineer or a computer science engineer.
So back in high school, we had an engineering academy
Mm-hmm.
where we did a bunch of different types of engineering, very obviously low level stuff, just little introductions to everything. And the one where we were soldering things together and playing with sensors and motors and programming it to all work together is what really drew my attention
Got
because
it.
I felt like that was a very uh, integrated discipline. I don't know. I felt like I could do something on my own and have it all
Got it.
work together.
It
Everything
probably
else felt a little more disjointed.
okay. So you felt that you are more aligned to your aptitude, and the discipline is more aligned. It's
Yeah.
something. Okay, cool.
Hmm.
Okay. Okay. So you have some experience doing part-time job in a winery or something, right?
Yeah, I was a manager at a winery for a few years.
Okay. Cool.
I don't have a lot of technical experience in the field, so I'm kind of just trying to put stuff in there that shows that I've been in
Yeah. Of course. Of course.
leadership
So,
roles, and
of course, that's very important. So, what did you learn from being working there? Like, you work with a lot of people, and that doesn't change, regardless of the discipline you go, right? So,
hmm
what did you learn by, what was the things? What were the things that you learned?
So I worked at the winery, and I also did security for a few years
Uh huh.
at hospitals as well. And those both, funny enough, had some overlaps in the sense that there was a lot of learning conflict resolution, but in very different ways. Because at the winery, we served a higher end clientele
Uh huh.
because we did a weekend pairing where we brought in a chef and he made 4 course meals that we paired with wine. And it was
Mm-hmm.
an exclusive event. We only did like 50 people a day.
Mm-hmm.
So these people expected to be treated in a certain way. And when issues came up, you had to resolve those. A lot of that was appeasing people while still making things work. And chefs themselves can be personalities. So sometimes you have to work with the chef to make things meet in the middle. But then also working at security, that worked with the opposite end of the spectrum. I spent a lot of time watching psych patients and the such, or people who were violent,
Okay. Oh,
and that was also conflict resolution, but in a completely different way. Sometimes you just had to set boundaries, say, "Hey, this is how things work here. I'm willing to work with you so long as we can work within guidelines." But there was also a lot of teamwork in both of those roles.
got it.
Yeah,
Okay.
because up at the winery, I had the most experience, so I was running things,
Mm-hmm.
but at the time I was 21. So it was kind of difficult being young, but also in a leadership role
Mm-hmm.
because I had a lot of people older than me who maybe didn't want
Right.
to listen to someone my age.
Got it.
So there's a lot of trying to find middle grounds and trying to work with people who maybe didn't want to normally listen to me.
Got it.
So I learned a lot about how to phrase things to get things done. Um, Maybe telling people to do something wasn't always the best way. Maybe showing somebody how to do something and suggesting that it works this way or it might be better this way, and letting them try it
Got
will
it.
show that, okay, this is the way that things are going to work best. It was
I
a
mean,
lot of
a
meeting
lot of
people at their level.
those are all very important skills because you know how it works in post silicon validation engineer is there are designers, okay,
Hmm.
who design the chip, and the designers want their chip to work right, and then you have the other end of the spectrum who are the where the product is going into, and they expect everything to be validated. See, it's there are a lot of parallels in that aspect.
Yeah, no, I could imagine there's conflict. Maybe designers say, oh, it works this way, but something's not working that way, and you have to say,
I mean,
oh, this isn't working without
that's true, but
offending.
design they're generally cooperative because you're not a customer here. You're still within the same team, right?
Yeah.
But there are parallels for sure. There are parallels. Okay, so I'm going through a skill set, right? In this
Hmm.
skill set, you have mentioned a couple of skill sets, important skill sets you have mentioned. Your experience with coding FPGA using Verilog. Okay, you're proficient with ADS, PSpice, AutoCAD. Okay, and quickly kick up others. So tell, like, can you explain to me what do you mean by proficient in all these tools? Because these are all very important tools. We use all this, by the way. We use
Okay.
FPGA, we use coding with FPGA Verilog, we use ADS, we use PSpice, we use AutoCAD.
That's
ADS maybe
awesome.
not to Axtec, but we use similar version of similar something similar to ADS. So because we are a lidar company, right? So we have there's an optical division, there's a mechanical division, there is a electrical division, and then there's the ASICs division, and there's a firmware division. So you have a and there's a software on top of it. So you have everything here, and as I said, since you are a small company, um, you get exposed to all this.
Hmm.
This is not those companies where you have two types of companies. One where you are kind of focused on one role, and you really don't know what's happening around. We are more of a yeah, you are focused on one role, but definitely you're very well aware of your peripheral on the peripheral disciplines.
Yeah.
So yeah, can you explain to me what level of proficiency do we have with all this?
They vary quite a bit. The vast majority of that is things that I've learned through schooling. So it's like I worked with it for how long is this semester? 4 months, and I kind of learned the basics of it. I operated with it. I performed labs and I wrote reports with it. That sort of thing.
Mhm.
My highest level of proficiency is probably MATLAB, just because that's what I'm using right now, and that's what is most recent and fresh on the mind. Because that's what Shriners decided we use, so I was on board with it.
So what were you doing with MATLAB right now? What are you doing right now?
Oh, so right now, children with cerebral palsy have different patterns of walking that we think we can categorize to help treat them. At the moment, there's no universal treatment for kids with cerebral palsy walking issues. Every single doctor is working off of their own experience. My work is I'm trying to categorize these kids into these categories so that we can say, if kids walk like this is how you're going to treat them. But those categories don't really exist yet. So my MATLAB code looks at parameters of their gait and then sorts them into these categories. Primarily, we're focusing on the flexing of the knee, ankle, and hip. So my code just pulls data of, I think we're looking at 1,000 kids.
Got it. So can I ask you a question? Why did you choose to use MATLAB?
I didn't. I was told we were using MATLAB.
I see.
Yeah, I came in and they said, hey, MATLAB's what we use.
Okay, got it.
Because this is a research grant, so I'm only working here for a short period of time.
Got it.
And once I'm gone, they want to be able to continue to use it on their terms, basically. So they wanted it built in MATLAB.
So was there any a lot of mathematical modeling involved?
A lot of it was just trying to find the interconnections between the medical side of it and the quantifiable side of it, because there's a lot of the things where the doctor would say something and I'm like, okay, that's great, your eye can see that just fine, but I'm looking at data. Where can I make that, what you're seeing, into data so that I can categorize this 1,000 kids at a time rather than you looking at them one by one?
I see.
So that was a lot where more of the time was spent. And then from there, it's trying to figure out how do I process this many kids in a reasonable amount of time, um, optimizing the code, because
Got it.
it's a lot of simple uh, if statements basically, because it's just categorization.
Right. What
But
about other coding languages? Are you proficient? Are you familiar with things like Python?
yeah, no, I wrote a bit of Python, quite a bit, back in community college.
Uh-huh.
That was 4 years ago, so I'm a little rusty. But I did go through a quick thing with Ishwar. He had a quick test for me, and I got that down.
Cool.
Um, I've used a little bit of C in messing with things like FPGAs and whatnot.
Uh-huh.
I've played with. I had to do a little work with assembly. I hope I never see it again. uh,
Yeah,
and then
that's right.
yeah, I worked with Verilog for a semester.
Okay, cool. So yeah, okay, that's pretty cool. So it looks like you have got you have touched MATLAB. MATLAB is what you're most proficient with, but you have worked on Python and other things. You're familiar with the. It looks like you have the foundations to learn different languages and different tools. But you
Oh
wouldn't
yeah,
call yourself an expert in anything. Maybe MATLAB to some extent, but is that a fair way to categorize it?
yeah,
But
definitely,
got
because I
enough.
have that base.
You have that enough base to learn a new tool. Okay.
Absolutely,
Okay,
which
cool. Very cool. So, let me ask you a few questions, okay?
for
So,
sure.
your background in, just to get an idea, in Sacramento State, what are the courseworks what was your coursework?
Uh, so I actually have that in front of me. Um, I got my bachelor's in electrical engineering. I got took a focus in control systems.
Okay.
Uh, Most recently, I was taking things like I took a course in machine vision, lots of digital control systems, physical electronics, uh, feedback systems.
Mm-hmm.
I took a short course on robotics. I kind of learned about motors there and some of the 3D motion, uh, moving arms and whatnot. That was a lot of going back to that 3D space that I'd learned in Calculus 3. That was really interesting. Uh, I took a course on electromechanical conversion,
Mm-hmm.
which I thought was really interesting. I have intro to microprocessors. I did some stuff with signals and systems, and of course, probability and random signals. I touched a little on some network analysis as well. And
Mm-hmm.
then, of course, I had the basics of logic design and circuit analysis, that type of thing.
Got it. Got it. Okay. Cool. So, yeah, let me ask you a question. So, since you mentioned, let me see if I can pull up a whiteboard here, share screen. So, I'm going to pull up a whiteboard here, okay? So, you mentioned about feedback systems, right?
Yes.
So, let's say, oh, why can't I? Oh, boy. You know what? Okay, cool.
All right. I see.
I see. Okay. No, I was worried that what happened is I came home pretty late yesterday, so I forgot to get my laptop charger.
Ooh.
No, I was worried so I'm having some trouble here with this. Hmm, it looks a little flaky. The Zoom connection looks a little flaky, but let me try it again. Okay. Yeah, I can't really draw with this. Let's see. Okay, that's fine. Let me ask you the question verbally.
For sure.
So, now let's talk about feedback systems. Okay. Uh, I have a I have an amplifier. Okay, and I can connect it in a negative feedback scheme. So please let me know if you're following. Okay, what I mean.
Okay.
Okay, so and if you don't follow, please let me know. So we are connecting in a negative feedback scheme.
Okay.
So do you need to be concerned about stability?
Negative feedback meaning that when
Imagine
you're.
an amplifier. There's a positive and a negative input to an amplifier. Okay,
Hmm.
and
Oh.
output is a gain A. Let's say A is the gain.
Hmm.
A times the difference between positive signal and negative signal. Okay, and I
Okay.
connect the output back to the negative terminal. So I have only
Hmm.
one input now. I give the input to the positive terminal.
Yeah.
So did you picture yourself what I mean?
I think so. Yeah.
Yeah. So
Yeah.
let me try to draw it. It might be easier if I draw it. Okay.
Hmm.
Yeah, but I can't draw. So what I would do is I would show you a
Do you mean something like this?
oh, you already showed?
I
Yes,
drew
exactly.
something real quick.
Exactly. Okay, I was just looking for this. Okay, great. So would you do you see any concerns with do you need to be worried about stability here?
I don't recall, to be perfectly honest.
No, that's not grounded.
Oh, that doesn't erase.
Yeah.
Sorry, I have a
No,
pen,
that's
so I'm
okay. No
used to it.
worries. No worries. So it's not grounded, but okay. So do you know the concept of poles and zeros to some extent?
Of ports and zeros?
Poles and zeros.
I Oh, yes, yeah.
Okay.
Um, I do believe you need to be concerned about stability.
Okay. Can you tell me what are poles and what are zeros? You remember?
Um, it always helps me to think of it graphically, but
Mm-hmm.
poles are where your system's going to go asymptotically,
Mm-hmm.
asymptotically. Oh, that's I have a Surface, so I can normally flip around my pen and it's an eraser.
Oh,
So
cool.
I keep trying to erase and keeps writing. Um, so we'd have a pole right here, and a zero would be where it intersects with our x-axis.
Okay. So have you heard about anything called the Bode plots?
I don't think so.
Okay. All right. Okay. No worries. So so in control systems, in a linear control system, right? There is something called Barkhaussen's criteria. Have you heard about that?
I don't think so.
Okay. So something about the oscillations. What causes oscillations?
Hmm. Okay. Oscillations are going to be caused by something in the system feeding back in a way that is increasing, so
Right.
that it's going to continue to oscillate.
Right. So exactly that's what. Can you draw the? So unfortunately, I'm not able to draw. But if you can draw the same scheme that you just drew, right? The feedback.
Yeah, here. So like this, and then
Right. Exactly. Okay. So now this is a negative feedback. So what happens when you give a positive signal, right? The output goes higher and subtracts from the negative. So there's always a fight going on, right? At some point it stabilizes. Okay.
hmm
Okay. So now there's a gain involved here. So if you can write the equation for it, right? V out. Call this. Let's say this is a. Let's draw it this way, right? Your output is, let's say, V out. Okay. So let's assume. Can you draw this circuit in an open loop configuration where you don't connect it in feedback? You just connect, you know, just a V in and I mean VIP and VIN, the positive and negative. Okay. And let's say the gain of the amplifier is A. Okay.
hmm
Then we write an equation. V out is equal to A times VN minus VP. Okay. Okay. So okay, got it. Okay, cool. Now you connected in a negative feedback configuration, correct? Right. Okay. So what
Yeah.
happens now when you connect in a weaker? There is no basically a VI and V out become the same thing, right?
Yeah.
So can you tell me what happens to V out now?
It's going to start feeding back into itself, which doesn't that mean it's going to oscillate and become unstable? Because
No, can you
it's
write
going
the
to.
equation there?
Oh
Use the
yeah.
equation. Very difficult to. Yeah. No. So yeah, I would write the equation again. Just A times V in minus VP. Okay, this is so what, and now your V out and V in are the same. So what would happen to your equation?
So it's gonna keep feeding back. It's gonna be V in, but that's feeding into itself. Mm, it's feeding back.
So I think the equation is a little misleading what you have drawn. Okay, I would rewrite the equation just to make it more easy to for you to. Okay, so let me see if I can draw. Some reason I okay. So I would say the
Okay.
equation looks something like this. Okay, you have V out is equal to A times VP minus Vn.
Hmm.
This is what the equation would look. This is what the equation was.
Yeah.
You agree with me, right?
Yeah.
But now what you have done, you have made V out is become Vn because you connected them together.
Hmm.
Now V out and V in are the same thing because they're both shorted together. So what would
Yeah.
happen to what would how will the equation look like now when you do this?
So effectively, what we have is something like this. We're
Exactly. So how will yeah? So then what is the V out then? You can do the math and say calculate V out, right? Exactly what it is.
yeah. That's gonna be
Exactly. Okay.
mhm.
So can you can you write in terms of V out rather than VP being the independent variable? You know what I mean?
Yeah.
VO only on one side and everything else on the other side.
Hmm. I am blanking on that because I know that I'm gonna get A is gonna be back on that, and
Right.
then
So then you can take VO out, right? Like VO is a common factor here. So
oh
yeah.
yeah. Um, can I? Oh god, that's writing, not scrolling. Boom. Oh no, that's gonna be.
Yep, that's right. Right.
Keep running out of
Absolutely.
space,
So if you take 1 plus a
and
to
then
the
I just
denominator, right?
divide by that. Yeah.
Yeah. Okay, perfect. So now here's the interesting thing, right? This is a negative feedback configuration. Okay.
Hmm.
Here's the interesting thing. What happens if A, the gain becomes very, very large?
Um. So this is going to approach. Your numerator is going to approach infinity, but your denominator is also going to approach infinity. So it's dependent on your voltage input. It's probably going to go to infinity, more likely than not.
Okay. So let's look at this way, right? Your VO is equal to A by 1 plus A times VP, right? What happens to this as A becomes very large?
This is going to go to infinity. This is going to be infinity plus 1. So it's going to approach 1?
Exactly, it's going to approach one, right? Which
Yeah.
means your output is going to be equal to your input,
Hmm.
right? So this configuration is called a buffer. They call it a buffer because whatever input you give here,
Is what you're getting out.
what you're getting out. And why is it important is because a lot of times you cannot drive a very big load or something. These are basically what you call op amps, operational amplifiers,
Hmm.
and they're designed to drive very big load. Very big load means very large capacitance. Okay,
Hmm.
but let's say you have a like your electrode, what you mentioned, right? A very weak signal. You that weak signal, if you connect it to a big load, the signal is going to die down. It cannot drive it. Doesn't have the energy.
Yeah.
So what you do, you connect it to something called a buffer, which is a very tiny load. Okay, and all you want to do is you want to replicate this signal at the output so that you can drive a big load and make use of that value.
Yeah. So it's easier to see the signal coming out.
And
That
we use
makes
a
sense.
configuration called unity gain configuration. Okay,
Hmm.
that's using
Unity
negative feedback.
gain. Yeah, that's familiar.
It's called unity gain feedback. Now here's the interesting thing. It's pretty stable. However, there is, and I'm just telling this for information. Okay,
Hmm.
there is a delay involved. Nothing is instantaneous, right?
Yeah.
And that's where your poles and zeros kick in. It basically tells you the delay. It basically describes the delay between your input and your output.
Okay.
So now, if you have a DC signal here, then yeah, great. You don't have to worry. There's no delay. But
Hmm.
if let's say you have a moving signal, right,
Yeah.
then this V out will not track your V in exactly with the delay. They'll have some delay associated with it.
Yeah. That makes sense.
If that delay happens to be, you know, like let's say this is a sine wave, okay?
Hmm.
Let's say if this delay happens to be 360 degrees, or this is
Yeah.
supposed to be negative feedback, right? So what I mean is, it's supposed to be a negative feedback, but because I'm giving positive, your signal is supposed to be, it's supposed to be, whatever you give, you're supposed to get the same thing here. However, if there is a huge delay within the amplifier, then let's say you gave a sine wave, you will see a phase shifted version of it. Like there'll be a delay. It looks
Yeah.
something like, now you're asking for, now this is when things will start oscillating.
Yeah. Oh, I see that.
So yeah, so what happens is, you go through this analysis of control, you go a control system analysis, or a pole zero stability analysis, where you have to compensate this in order to never ever see this oscillation. Because for oscillations you don't need to give anything. There'll be noise picked up from nature which will have this frequency content, and it will start amplifying itself, and all you'll see at the output is start oscillations. So
Mm.
that's where this stability kicks in. Now,
Okay.
stability is nothing but analyzing the delays through an amplifier. I just gave an example of an amplifier. You can take any system.
Yeah.
You can even take humans, right? Like let's say you give a positive input to your friend, okay, and by the time he gets an input, there's a big delay. It could actually turn out to making him unstable. You know what I mean? It can be modeled in a lot of ways. I'm just giving an example, right? Any
Yeah.
can be modeled into any system, but this is an electrical environment, how it would look. But uh, it's a modeling thing. So this is a, yeah. Anyways, let's give you some idea. Now,
Hmm.
positive feedback is slightly different. Positive feedback is, you're intentionally not, like, let's say that it was the other way around, right? You had, this was the, let's say this was the input negative. you know you give an input here, or I mean you gave an input here, you got this output, and you inverted it again, inverted it, and then you again gave it here. So this is intentionally doing positive. And you do
Oh,
this when you do this when you want an oscillator, like you need an oscillator at times, right?
okay.
But so then you do a positive oscillator. You intentionally do this. There the problem is different. You intentionally trying to make a system unstable. But
Hmm.
yeah. Anyways, that's just some idea. Anyway, Ryan, I think that's all the time I have. Nice talking to you. Uh,
Yeah.
I have like few more minutes now. This I generally reserve the last few minutes for you to ask me any questions that you want. So, do you have any questions for me?
Uh, Not really.
Okay.
I think I'm good. I want to apologize for running late. I
No, no
didn't
worries.
realize it was multiple rooms.
Okay. Anyways, I'll let you get on to the for rest of your day.
For sure.
Nice talking to you, and all the best.
You too. Thank you. Hello?
Hey, hi. Hi, Ryan. How are you?
Good. Fantastic. Sorry for that phone call. That was a needy calling me,
Okay.
so I thought I was missing something.
Yeah, I thought it was a little bit behind, was running behind, so I just wanted to confirm on it. So I asked her to check.
Oh no, you're good. I was running a little late too. I ran a little over with Roger.
Oh, okay, okay, no problem, no problem. So how are you doing so far?
Good. You guys are all really friendly, and I appreciate that.
Okay.
Yeah, this is my third interview today, so I think I got two more after you.
Hey, how are you feeling? How are you doing so far?
Uh, Good. Uh, this is my longest interview yet, so I was a little nervous coming into it because I'm like, oh man, 5 hours of interviews, but not as bad as I expected. You know,
Okay,
it's pretty easy going. You guys are an interesting lot.
okay, great. So, do you understand the position so far? Just let me just ask you. Do you know the position? Do you have any questions on it?
I think I understand it. It's been explained to me. Post silicon validation is the way that I keep thinking about it is you're the guy that's checking that we're meeting the data sheet expectations.
Mm-hmm.
So, and then since you guys are a startup, it sounds like I'll be following the product or my piece of it. I'll be following it into integration, which sounds really neat, even though that is, as they've stressed, far down the line.
Okay, okay. Yeah, so let me explain you my role. I'm a product engineer here, right? So basically, we have ASICs team, right, which designs the chips, which goes into the our LiDAR products, right? So we design, so chips been designed, and then once it comes back, so I'm the one who interfaces and make sure that we meet all the specifications and run the qualification of the chip, like reliability qualification. We have to make sure, right, that ICs are going to meet certain reliability standards, right? Um, so I'm doing that, as well as I will be, a part of a post silicon as well.
Hmm.
So mostly what I do is I interface on the ATE side. Okay, so making sure the test we can do automated testing of the chips.
Okay.
And in your post silicon validation, once chip comes back, you put it on a system, right? Or on a bench boards, right? And check all the parameters and stuff, whether it's functional or not, and it meets all requirement. And we replicate that on a ATE side and make sure that all the blocks of the chips get tested, and
Okay.
and chip is performing to all the expectations. So when you implement it on a board, on a system, right after ATE testing, you don't have to redo anything, right? It's good part is good part.
Yeah.
Yeah. So we will be working very close together. It's going to be, a lot of things on it, right? So this is a position in which, we will be interfacing it, and I'll be looking into the data. We work together to bring it up on a ATE side as well as on the bench side, right?
Okay.
So yeah, so once before you integrate to the system, yeah, system level isn't kind of a step ahead, right? You building it right now. In when I take is a black box chip as a input parameters, output parameters, and whether it's matching, right?
Hmm.
So that's what it is. Okay. Yeah, so we are, this group is bringing it up. We have, Velodyne is a leader in the LiDAR industry, right? So okay, so do you have any questions regarding company or anything else?
Um, what is your day to day like? Like, how far are you? What's your horizontal? Are you doing something different every week, or do you have a more focused area of expertise?
Okay, things are dynamic here, right? The products
Hmm.
are, well, there are a lot of products, right? But so things can change very fast, right? As well as sometimes you have to do very repetitive task. It's going to be repetitive task. You keep on doing same tasks again and again for some time, or some instances it would be every day, you, or maybe every few hours you're going to change the things what you are doing, right? So yeah, so that would be the life.
Hmm.
So it's a fast moving pace. Things change very fast so far, right? When you are developing things, right, it's always change very fast.
Yeah, for sure.
Okay. So yeah, you need to adapt both. Sometimes you have to do repetitive tasks to make sure things are right.
Yeah, that makes sense.
Okay. Okay. So yeah, so main things is okay. I saw your resume. I was looking. You went to Sac State. Looks like.
Yep, graduated this spring, just 2 months ago.
Okay. How was your graduation? You guys are able to go
Oh,
and walk.
no, it was they called it a car commencement. We drove through the campus in my car. and they had like
Okay.
tents set up, and there were faculty standing on the sidewalk cheering, and it was interesting, something different.
I spent I did 1 semester in Sac State.
Oh, how was it?
It was good. It was a while back, years back. Um, okay. So what I see is that you just graduated. Why you took electrical engineering? Just curious. Why you choose to be an electrical engineer?
We actually had an engineering academy back at my high school, so we got to try a breadth of engineering fields. I've always been math and science inclined, so I knew that I was going to be doing something in math and science. So I joined this academy, and we did this again, this whole breadth. We did mechanical things. We did some like 3D modeling stuff. We played with statics, bridge building. We did things like robotics and electronics, and that was what spoke to me. I really kind of enjoyed playing with sensors and then programming it to work together. We did some hand soldering, and I really enjoyed watching these things come together. Electrical engineering felt like a very complete field where I could see something from beginning to end. I could put the sensors together, I could get them working, and then have it all functioning together. And I found that interesting. I liked being able to be involved in all parts of it.
Okay. Okay. That's good. That's good. Yeah, it's always a passion. The passion you follow that helps, right?
hmm Yeah, no, I liked the whole integration of it. It was fun seeing everything come together. Everything else was a little more. The mechanical stuff was like, okay, we ran the numbers, but we can't build this thing. I was like, okay, well that's interesting, but it's a lot cool to see it come together.
Okay, great. Oh, great. So right now, I think you work with some in a hospital, right? So what you do in basically?
So at Shriners, I'm actually on a research grant where I put together a program that's going to help categorize kids with cerebral palsy into categories. At the moment, kids with cerebral palsy get treated by doctors based off of their experience because there's no documentation on how to treat kids. So, what we're trying to do, every kid seems unique, but really there's some overall patterns that you can kind of group kids into these big categories that can help you say, if this kid falls into this category, this is how we would start to treat them, or like these are things that we might look at. And I'm working with physicians to develop those categories and then quantify them. Uh, right now, I have a MATLAB script that I'm bringing in data, and then I can show that, hey, look, I put these kids into all these categories, and they all make sense clinically.
Okay. So how you sort them out on a MATLAB script? You use where the data comes from? Somebody inputs it, or it comes from your database, or?
We have a large database that the Shriners Network has put together. So I have to go into the database by hand, write SQL, and pull it into an Excel sheet. But then from that Excel, my programmer will read through and find the parameters it needs.
Okay.
Right now, I think we're processing a little over 1,000 kids, and then each kid has multiple trials worth of data. So that also helps us see some of the consistency of not only the kids, but the categorization itself. Where I am now, the project's basically complete, but the database has issues. So they've actually had me trying to fix some of the database since they still have me on, and what I've been brought on to do has basically been finished.
Okay. Great. Oh, that's great. That's great.
hmm
So do you like it?
I think it's interesting work. It's never boring because you always come in and you're always trying to figure something new out. Um, it's been a lot of fun trying to find the interdisciplinary connections between the two, my engineering base and the medical side of things, and trying to find that common knowledge and that shared base has been super cool. Um, I've learned a lot, which I really appreciate. I've written in SQL for the first time. I never touched SQL until I had this job. And just working for Shriners, there's definitely a certain amount of being able to feel good about my work. You know, like I'm helping kids. I don't know, it
Okay.
feels good, you know?
Okay. Oh, that's good. That's good. That's great. No. So, Saxtate, what coursework you did? The
At,
key electrical engineering courseworks. What courseworks you did, and what was your best class?
well, last semester I took physical electronics, intro to machine vision, digital control systems, and my second semester of my senior design course, and I got A's in all those. But I've also dabbled in things like robotics, some probability and signals and systems. I played with electromechanical conversion, which is
Mhm.
more for like power engineers, and then a bunch of other things like that. I covered all the basics: analysis labs, logic design, circuit analysis.
Okay. Okay. Yeah, great. Uh, I was there. I guess who was Kumar? There was one of the professor Kumar, right?
Yeah. I had Kumar for a couple classes.
Yeah, I took a class under him that
Yeah.
time.
Oh, what did he teach?
I guess basic logic circuits and stuff class I took under him. I guess.
Oh yeah, he
Oh
does
wow,
teach
he's
that.
still there. Wow.
Yep. Nope, I
Yeah,
had him. I think it was fall 2020.
great,
Yeah.
great, great.
I mean, of course, it was online, so that was a bit different, but
Okay.
no.
Yeah. No. Yeah. No, I still remember that class.
Oh,
Great.
these professors stick around forever. I mean, I've had people who are like, "Yeah, I was there 30 years ago. Do you know so and so?" And I'm like, "Yep, I had that professor."
Yeah, it's a passion, right? The professors. It's a passion of teaching.
Hmm.
That's how you stay, right? So
Oh,
any
it's
job, if
crazy.
you're a passion,
And just
and
whole
you,
generations of engineers passing under these people. It's amazing.
okay, great, great. Uh, so yeah, so okay, let me ask you a few questions on electrical engineering side,
For
right?
sure.
Just quickly check what just basics, right?
Hmm.
Let me share my screen. Okay. Hey, can you see my document?
Yes.
Okay, it's a basic question, Sam, right? So in this one, what do you think the current in the circuit will be?
V equals IR, so that's going to be 120 divided by 60. That should be 2 amps.
Yeah, that's good. That's good.
Yeah.
Next one, what do you think the current across the 60 ohm?
If I'm seeing that correctly, there's no current because there's just a strip of wire going around it, and it's going to completely bypass that.
Won't be there won't be current across. Okay, there won't be any current. That's correct because you're short circuiting it, right?
Yeah.
Great, great. Uh, can you tell me the resistance between these two guys, between A and B?
I'm not seeing the next problem.
Okay, can
I'm
you
still
see
seeing
here?
the top.
Okay, can you see this?
Oh, okay. Yep. It just changed.
Okay.
That's going to be 4 plus. Oh, what is that? Do you mind if I grab a calculator just because I'm.
Sure, sure. You can use it.
Yeah. Because what is it? It's going to be 1 divided by 1 plus 1 divided by 2. I remember it's inverses. Okay, so that's going to be 0.6, and that's going to be plus 4 plus 3, 7.6? 6666.
Okay, great, great, great. Okay. So in this one, right? Say this is my V1. I have 20 volts drop across here, right?
Okay.
Right. And here the current flowing from here is 6 amps, right? And what would be the voltage I will require for this battery to operate on? So have you learned the KVL, Kirchhoff's voltage law and current laws?
Yeah, I haven't I haven't used them in a year or so, but maybe a little longer. What is this? This is going to be loops. We're going around. We're dropping 20 volts across that. That's going to be 10 ohms. Six.
So this is 6 amps current, right? And it's flowing through here, right? Going
Yep.
from here to here, right? So this
Yeah.
node will here, right here, it will be 6 amp right before entering this node,
Yep.
right? And here I'm going, here I have 20 volt drop.
Yeah, which means we're getting 2 amps across that.
Yeah, okay. So 2 amps are going through here, right?
Yep. So 4
Okay.
amps are going across the other one.
Okay.
So 4 amps across the 2 ohms means we're dropping 8 volts across the 2 ohms.
Okay.
And then we still have that 4 amps, and it's going across a 5, so that's going to be dropping another 20. So I think in total we dropped 48 volts. So is 48 volts going to be our battery? Or am I missing something at the battery itself at node 2?
So okay, so you're correct here. Means not answered, but I'm just trying to understand your logic on going on. Okay, right? So you
Yeah.
have 8 volts going on, right? So your V1 is 20 volts, right?
Mhm.
Right. And so what would be the V2?
That should also be 20 because we're going to have a 4 amps across there, and 4 times 5, 20. Yeah.
So 20, and you already dropped 8 volts here, right? So 20, right? You got dropped 8 volts here, right? So
Yeah.
so what the voltage, because your current going here, you already dropped some voltage. So the current, so here same current going, but however it distributes it, right? Because there's another path. So it would be 20 minus something, right? KVL
Oh,
if you apply.
20 minus, it's only going to be 12 right there.
Okay, correct.
Because we have less amps going that way, some of the amperage is going the other way.
Okay, correct. So it's a 12 volts, right? Now, if you apply KVL here, it's going to be the same voltage across here. Whatever the voltage is here across these 2 nodes is the same as voltage here, right?
Mm-hmm. So
Right.
if those are both, that's 12 volts. That's also going to be 12 volts.
Yeah. So you need a 12 volt battery, basically.
Yeah. Because that's going to make sure that it's, conservation of energy.
Yeah, because these 2 are in series, so you add it up, the voltage drops.
Mm-hmm.
Right. The current stays the same, but the voltage changes. Right. Okay.
That tracks.
Okay. That's good. That's good. No worries. So in this one, right? Do you know the capacitance equation, voltage capacitance equations?
Not off
Can
the
you
top of my
tell
head.
me just a little bit about capacitance? What is capacitance and where you use it?
Capacitors basically store energy. They can be used to stop DC signals, which is going to remove any offsets that you have. And then I remember that capacitance in series adds, it's not inversely, but it's the weird one. It's like a resistor in parallel is how it adds.
Okay. Okay. No, that's good. That's good. So basically, yeah, it's a short-term storage, right? Time dependent, right? And it's a short-term storage capacitances. So
Mhm.
basically, what happens if I have like a signal changing very fast on a capacitance? What it will do?
If it changes super fast, it's gonna treat it as if it's just a regular wire. It's going to ignore it because it's going to be going so quickly.
Okay.
Short circuit, yeah.
Okay.
And if it slows down enough, it doesn't get through because then it's almost DC.
Okay. 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 Let me grab a whiteboard and see basic questions for the pets. So what are okay. Let me check. Okay, can you see this, right?
Yes.
You can see this whiteboard. Okay. Can you draw me a cross section? You studied MOSFETs, right?
A little, yeah.
Okay. Do you remember how the cross section of the MOSFET looks like, or
Physically or a diagram? Like,
diagram? Just if you can draw a cross section of a MOSFET. Like say I want to draw an NMOS.
how did we draw those?
Do you?
I'm not remembering off the top of my head.
Okay. Okay, I can help you in somewhat, right? So let's see.
Okay. I just checked my notes.
Okay, I'm just trying to. Okay. So the one you're okay. So this okay. Okay. So this is a symbol of capacitance, correct? Sorry, FET. So what it is?
It's basically just a type of transistor.
Okay. Okay. So say I have when I'm looking at the cross section, right? On a this is a you right, and then it should be something like this, right?
Yeah, then you have your N side and your P side.
Right. You have 3 connections, right? So you know what these 3 would be? So in your transistor, these are the 3 things, right? What are these 3?
Yeah. You have usually your input here, and then it depends on how you want this built. If you have your outputs here, or if it's going this way again.
So say input, we call it gate, right? And one we call it drain, another we call it source, right? Right?
Mm-hmm.
So this is your gate, right? This is your drain. This is your source, right?
Okay.
Okay. And this is your bulk. You call it generally grounded, right? say now if I want to make it as a, and there are two types of FETs, right? You know, right? NMOS and PMOS. Do
Yeah.
you know about that? Right.
I learned about it at some point. Yeah.
So, okay. Because if you want to say build an inverter, right, in your circuit, how are you going to build an inverter? Do you know how inverter works? What is inverter? Do you know the gates, right? The different gates, right? Inverter, AND gate, OR gate.
Yeah. So yeah,
So
that's going to be an inverter.
okay.
Ideally, you want your current.
So inverter would be something like this, right?
Yeah. Yeah.
Symbol wise, okay.
Mhm.
So in inverter, do you know we have one FET going in or two FETs we need? Do you know how it works?
I don't think so.
Okay, so yeah, so basically in this one, say if I want to make it NMOS, right? So I need P substrate and N, right? N is completely off in the sense when you don't have biases.
Yeah.
When you apply voltage here at the gate, right,
Mhm.
which is this node, when you apply voltage signal, transitioning like this, right? So it turns on this guy and the channel forms here and the current starts flowing, right?
Mhm.
Okay. So this is basically how it works. So in inverter, what you want to do when your input, what will be the input of the inverter and what will be the output of inverter? Can you tell me that?
Whatever you put in is flipped in a logic sense, but in another
Okay.
sense, this would be our gate, and our output would be our source.
Okay. 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 Yeah. So basically, what happens in inverter is basically when you apply, say, positive the signal, your output will be inverted. Right. This is logic 1 and this is logic 0. Right.
Yeah.
So output would be like this.
Mhm.
Correct. So basically, it works is this way. You have two FETs, right? Right. So this goes this goes this, and this is your output. So you need two FETs, right? This is your supply, VDD, right? Drain. And these two are tied, right? So what happens? This is one is NMOS, top one, and bottom one is PMOS, right? This is PMOS. So this is always off, right? And this is always on, and this is off, right? So when 0 volt apply here, it is on. When
Oh.
5 volt apply here, right? So when you apply this way, right? So initially you have 0 volts going on. So I have 0 volts going on. What happens then?
It's going to be flipped over here. We're going to be getting 1 because this is going to stay 0 and this is going to become 1.
Okay. Okay. So yeah. Okay. So this is 0. This is 1, right?
Mhm.
And what happens at when I apply higher voltage here? Turns on this guy.
Mhm.
But how? Like when I'm applying 0 volt here, right? This is off. So nothing is going here. This is off. So you have
Yeah.
5 volt sitting here. And this is a 0. So this should be 0, right? Wouldn't it be 0? Because you're looking at output here, right?
Sorry. So this is, in this scenario, we have a, sorry.
So if I have a circuit like this, right, and I'm applying 0 here,
Mhm.
right, what would be my output here?
We're going to have 0 here. This is 0. This is 1. We have our 5 volts being applied. Are we going to be the 5? I want to say we're getting 0 out. I'm not actually familiar with this form of
Okay.
notation. So
Okay. Okay. No. You're going in right direction. Okay.
okay.
Yeah. You will be zero out. You know why? Why you will be zero out?
Basically, this is closed, so you're not getting power through. Is what I'm thinking.
Hmm.
So it's basically just connected to ground.
Okay. Correct. Yeah, that's right. So I drawed an inverter wrong way. Actually, what I draw was a buffer, which is basically the
Okay.
same signal going to it, right? Right. Ideally, this should be my PMOS and this should be my NMOS, right? So what happens is when I apply 0, right, when PMOS is on and this is off, so you get same signal, you get inverted signal output, right?
Yeah.
Okay. So that's my inverter.
Yeah. Okay. That makes more sense as an inverter. Yeah.
Okay. Yeah. So I have this AND gate, right? You know AND gate, right?
Yeah.
Okay. I have 0 here and 1 here. What's gonna get? I will get an output.
That's going to be 0 because they both need to be high to be getting a 1 out.
Okay. And what if I make it NAND?
Not and. It's not and, so you're going to be getting a 1 out because not and is 1 unless they're both high.
Yeah. So not AND is basically you have AND gate followed by an inverter in simple terms, right?
Yeah.
Okay. Great. Um, I have seen that you worked on, you did some Python, you know Python somewhat, right?
Yeah. I worked with Python back at Folsom Lake. I had a couple courses back there. I haven't used it a lot since because it doesn't come up.
Okay.
But I did do a little demo with Ishwar.
Okay. Great. So, right. Yeah, I don't know much Python, frankly speaking. I'm on a different background, um, so I'm mostly kind of bringing up stuff for yield and all these things on the tester side, right? So yeah, I'm less familiar with Python on that, but logic. What it matters is the language is the one you can learn, but logic is the one we want to. Okay, quickly, right? This is if I want, say, how do I explain you on this? Okay, I want to create a top level algorithm. I don't want to go into the details how you gonna script it, but say for example, I have a problem where I want to, I have 10 data points, right?
Mhm.
Okay, it means 10 parts. You testing it, okay, on your bench board parts, right? You just build a board to test 10 ICs, right? You put it in, you have all the components here, right? And you're giving right signals input and you're trying to get output, right? And this is the part, each part in the board, you're in your socket, you're putting it, right?
Okay.
So when I was testing it, right? And every time when I see, I was repeating all this, each part I test 3 times,
Okay.
right? Okay. What happens is, okay, 3 of the parts pass all 3 times. Okay. 2 of another 3 of the parts fail all the 3 times consistently, right? And 4 of the parts out of 3 times sometimes pass, sometimes fail.
Okay.
Right? They're not consistent. Pass or fail. Like 3 times you repeat it, maybe one part pass 1 time, 2 times fail, another 3 parts pass 2 times, 1 time fail, right? So in this scenario, what do you think? What could be wrong here?
They're all getting the exact same inputs and the exact same outputs.
You exactly same repeating it, everything. Yes.
Yeah, if it's passing and failing sometimes, passing sometimes, failing sometimes. If your inputs and your outputs are saying something is changing in the system, what could be changing in the system? So potentially, one option might be that if you get a pass and a pass and a fail, something inside the chip is actually breaking, causing that third one to fail, or if you have pass fail, um, something
But
might
what if I
actually.
got like FPP? This is what happened on 4 parts, right?
Mhm.
FP, 4 parts in series. This is what happened when I run 3 times, right? When I'm putting in the parts here, and you will have some components, right? You might have some, say, input is one of them input is clock going on. You have a power supply turn on here, right? Say 5-volt power supply you're applying, right? And you're monitoring the output, what should be, whatever you get, getting logic 1 or pass. Let's take an example of your simple AND gate, right?
Yeah.
You're just testing an AND gate,
Mhm.
right? And this is what the result is coming to you, right? You build your board to test it AND gate, and you put it in on a socket, all the parts, right? One by one.
Mhm.
You put one part, test it, you get this result. Another part, you get this result. Third part, you get this result, and fourth part, you get this result. So what do you think? What could be wrong here?
Okay,
Is
so
it
I
the
thought
part where, yeah, what could be wrong? What do you think?
for the first two, it might be something breaking, and that's what's causing it not to work anymore. Maybe something is getting overloaded. For these two down here, uh, I'm thinking it's more likely that maybe your, for lack of a better explanation, your logic isn't resetting. Maybe you're getting a carryover from previous tests that's causing something to be altered. So maybe that first one failed, but the second one got some carryover of information. Maybe capacitors aren't discharging or something,
Mhm.
which causes it to pass.
But there is no capacitor here, right? Right now,
Right.
you are just
Right.
checking the inputs and outputs, right? You're applying an AND gate in it, but you are putting it in a socket. This is a chip, right? AND gate chip.
Yeah.
You have to put it in a socket, right? So you know how chip looks like, right? It has interconnects, right? So
Hmm.
what could be wrong here, right? You are applying here and trying. Means this could be, means if you do, like, you can think of it as, okay, I'm also happening this way also. F F P. It could happen anyway, right?
Yeah.
If this part you test say another 3 times, you might be getting F P F, for an
Yeah.
example, same unit. Then
PFP.
what could be wrong here when you're testing this part? When you're putting it in a system, AND gate system, this is your system AND gate, and you're looking at the AND gate output, this is what's happening with the part. Your system is not giving you right output. What could be wrong here?
Yeah. Something's inconsistent. That makes me think that something is not connected correctly, but
So
something
how
has
you
to be
debug it?
changing
Say for an
between
example, if you're
times.
getting this one, right? Let's put it this way in a simplest term. If you're getting this kind of output, what could be wrong here? What things you think of it could be wrong?
Hmm. Hmm. If you have a connection too close, you could have something short circuiting, but that should be happening consistently because we have the same inputs every time. Something is happening inconsistently.
So you have to apply, like, this is your 5-volt supply, right? You have to apply 5-volt, right? Logic
Hmm.
up and down in both cases, right? Then you will have a drain and ground connection here, right,
Yeah.
right, and the output here, right? You're gonna look into here, drop here, right?
Yeah.
So what things can go wrong in entire of this thing circuit when you're looking into it, checking into it?
My thought would be an issue with the ground or the drain somewhere.
Yeah, so you may have a connection problem, right? The
Yeah.
part in your socket may not be properly connected, or when you solder the socket, it is cold solder, so the connection kind of bounces up and down. So sometimes it's making connection, sometimes it's not making connection. In that case, you may get inconsistent results, right?
Yeah, something physically moving, so it's bumping sometimes and not others.
Yes, that's one of the reasons. So one of the things. So you start looking into that. You may start looking into your 5-volt supply. Is it consistent or not, right? You may look at your test board whether it's there any short or not, right? Short or
Hmm.
open or not, right? If you start, it means you have to start debugging it, right? One by one, what's going on, right? So you say, yeah, I'm getting consistent supply all the time. So this is not an issue. You rule
Starting
this
with
thing out.
yeah, start with the
Yeah,
testing
okay.
equipment.
You check all your pins to connection to ground and supply in
Hmm.
this one board, whether you have shorts or open. Okay, if that's not an issue, then it may be a part issue, real, right? That part has internally, because it's a IC, end gate IC. So it may
Black
have
box.
internal, yeah, black box. So it may have internal interconnect. So you have to start, okay, yeah, what could be wrong, right? We have to figure out.
Yeah, that makes sense. I did a lot of this with my senior project because we built the whole thing by hand before we founded the ICs. So there's a lot of put things together. We were using breadboards just to start with, so it was a lot of put things together and then find the oscilloscope, put in a signal, and see where the signal's going. Make sure that you're getting what you're expecting at different parts. And
Okay.
then when you get to a certain part and it's dead, why is there no connection here? Why is there no signal?
Yeah. Yeah. So it could be a board problem or it could be a part problem, but you have to start, we have to figure out what it is, right? It's a real board or what. And
Hmm.
some of this thing, we really do it. That on an IC level, we have to figure out whether it's a board test board issue or our vectors issue when you're supplying the input signals, or maybe, right? Whether whatever you want to apply, say you have a truth table 00100111 for AND gate, and only this output produces output 1, right? This doesn't produce, right?
Yeah.
Right. Okay. No, that's fine. Fair enough. That's fine. Yes. Okay. Last question for me on this one, right? Technically. Okay. So what happens if I am testing my AND gate, right? Let's just stick to AND gate,
For
right?
sure.
And if I have to test my AND gate, what vectors should I be applying? What input signal should I be applying to make sure my AND gate is correct? And I want to apply the minimum. So if you apply all 4 vectors, you know your AND gate works, right? And your output you will check. But I want to say I don't have time to put all 4 vectors, right? I can only apply, say, 2 vectors, right?
Hmm.
Which two? Then how do I test it? Not I don't have to apply. I don't want to apply 4 vectors to test it, right? I just want to apply 2 vectors to make sure my AND gate works.
Yeah. Well, obviously you have to have one because you have to make sure that you're getting your output. If we're just picking another one at random, I don't think the other one matters too much. Terribly. We could throw in 0, 0 just to make sure that it's not going live when everything's low.
Okay, that's correct. That's fine. Yeah, that's right. That's right. Okay.
Yeah, I'm sure an argument could be made for one of the other two, but
Yeah. Yeah, but ideally, if you're constrained, then you will use the most extreme cases in each side
yeah, that would make
to check
sense.
your parts. Right.
Hmm.
Okay. No, great. Good. So, hope you're okay, right? Feeling well. So don't
Yeah.
worry. Yeah, I know this is your first interview, and yeah, I know my first interview. It's tough always.
Oh yeah, no. Especially because I'm trying to break into the field. Yeah.
No,
You know.
yeah. So, okay, tell me one thing. What is the toughest challenge you had in your life so far, and how you dealt with professional or
Yeah.
personal? Whatever you want to share. Whatever you want to share. It's open ended, right?
Yeah. Um, I really like problems that are hard because I get a lot of satisfaction about bashing my head against something until I figure it out. But I think some of my hardest issues are actually interpersonal. My current project, I was working with a friend, and we just had different design approaches, and that was difficult to reconcile at times. He wanted to try new techniques, whereas I wanted to stick things that were tried and true that I knew I could do. Um, and we're also working on the same project, so we ended up working over each other sometimes, where sometimes I would do something over his work, or he would do something that nullified my work, and it was kind of frustrating trying to figure out how to get that to work at the same time. Um, this was by no means my first project, but for some reason, this one uh, was just difficult to get everything to work together.
Okay.
So what we ended up doing was we actually set up systems so that we we implemented version control. Hilariously, was the simple solution, where anytime we updated something, we would leave the date, our initials, and back it all up. And from there, we were able to work on the same thing without creating issues for each other. And then he would sometimes take his approaches, and sometimes I could incorporate his work into mine. Sometimes he would see something that I did and make it work together. And because we were still working on our own things, but on the same project, we were able to bring it together in such a way that we weren't wasting as much time or effort anymore.
So what happens if you means your friend he's I presume is a good friend, and you don't come to a conclusion on a methodology, right? In this
Mm-hmm.
case, you had a different methodology, right? You can't come to an agreement on your methodology. You have your coworker, right, for an example,
Yeah.
and you're working on it. You can't come to conclusion on the same methodology. What do you do? What can you do? How are you going to solve it then?
If we can't reach any understanding at all, honestly, I hate saying this, but I think that you have to escalate it. Ask somebody above you, which direction do we need to be taking this?
Okay. Okay. No, fair enough. Yeah. First, you try to solve yourself, right? Try to
Yeah.
try to explain
No.
yourself why you doing this, why you taking this approach,
Yeah,
right?
this is why I want to do it this way. I think these are the benefits. But also, another important thing is to try and be open-minded. I don't always have the best way. I know that for a fact. I'm not always right. Um, so it's important to also try and understand that maybe his methodology is correct. Maybe he's in the right here. So I'd always prefer to solve something interpersonally before having to escalate. But if there is no progress to be made, you need to ask somebody to
Okay.
assist.
No, that's fine. That's fine. Uh, okay. Okay. So what's your what do you like? What do you play? Did you play any in Sac State? Did you play any sports?
Nothing at Sac State, but I used to play football in high school. I played baseball before that. Um,
Mm,
yeah, nothing recently though. Got caught up on my studies and kind of let it all fall behind.
okay. Okay. No, no,
Yeah,
that's
no.
true. We have.
Nowadays, it's mostly tabletop games and video games because that's what I have time to, squeeze in an hour.
Great, great, great. No, that's true. I still remember the Guy West Bridge there. I don't know whether it's still there or not. University Avenue to go there. Go to the
Oh,
Sac State on the right on the back where E building is.
mm-hmm. No, I didn't have any time to keep up with that. And then, of course, my last year was COVID, so everything was
Uh,
shut down anyways.
Great. Do you have any questions for me?
I think I'm satisfied.
Yeah. Um, so what motivated you for Valorine? What do you like about Valorine?
Um, I think LiDAR is a really cool technology, and I want to be involved in the basics of it. I realize we're at the base level, we're validation, we're looking at ICs basically, but I'm just excited to be a part of it. You know, I want to see something that I
Mhm.
worked on. I want to see where it goes. I want to watch that chip that I helped validate become something. Whether it's the self-driving car or whatever it gets implemented into. I think it'll be fun
Okay.
to say I was part of that.
Okay. Oh, great, great, great. That's good. What do you think in 5 years you're gonna be? You're gonna be. Uh, what do you think about yourself on 5 years? You're gonna be working on a systems, on a chip, or a software side? What do you see?
I think I see myself sticking with hardware. I think hardware's more interesting. I appreciate something that's tangible. Uh, 5 years, maybe. I think it'd be interesting to get into design. I think that'd be fun.
Yeah.
You
Oh,
know,
great.
I'd like to work my way there eventually, but
Great.
we'll see what the future holds.
No, no, that's good. No, that's good. That's good. You need to have a goal, right, or something, goalpost, which
Hmm.
you can see
Yeah,
and
no,
try to achieve it.
absolutely. I mean, I have no issues with validation. It seems interesting, but it's not my end goal, you know?
Yeah, no problem. Great. You have any questions for me?
I don't think so. I'm good.
Okay, great. No, it's really nice. Really nice talking with you.
You too.
It's good. Yeah.
Yeah, no, I'm
Really
looking
great.
forward to my next two.
Okay. No, good luck. Right. You did well.
Appreciate
Okay.
it.
Good luck.
Thank you.
Okay. Bye, and have a best of luck. Okay.
Bye.